Good day, students. During the last several lectures, I have been discussing issues related to energy and environment in general, and also sometimes with specific reference to non-ferrous extraction processes. This will continue for another 3 or 4 lectures, because there are a lot of things I would like to communicate to you. Maybe someday some of you would be in a plant which is dealing with non-ferrous extraction processes. I would also like to tell you what would you do if you are a manager of such a plant. What procedures would you adopt to check environmental degradation. Now, let us come back for a quick review of the effects of extraction processes on environment. I mentioned this before, but let me mention them once again. Look at the slide. To start with, we have mining activities, which is causing depletion of natural resources, deforestation, dust and fines, spillage during handling and transport. When we come to the actual process, there would be emission of poisonous gases and fumes, generation of debris, fly ash, sludge, slag, all kinds of solid wastes. There would be spillage of lubricants, hazardous chemicals and wastes, many in liquid form. There would also be noise and vibration, which sometimes we do not take note of. But noise and vibration also causes noise, create noise pollution. It causes discomfort. It is not good for proper work environment. So, they also go into the category of environmental pollution as we defined earlier. So, every activity from mining to processing has an effect on environment. There will also be effect of downstream processes, where after having produced the metal in the bulk, we go for making intermediaries or consumer products. There would also be effect on the environment. So, every plant has to have an environmental policy, not only because the government and other regulatory authorities want them to, but hopefully the management should on its own have an environmental policy, because as I have mentioned earlier, spending some money for combating environmental pollution actually brings in benefit in the long run. And we have discussed what are the benefits that come when the environment becomes better. Now, the awareness is growing, there are training programs, there is pressure from the government, from the society, from NGOs, from national and international bodies. So, it becomes imperative that every industry has an environmental policy, more so for metal extraction processes, which tend to be the most polluting. Now, a policy would involve the following. First of all, the management has to set objectives and target review. It is not enough to say we would be cleaner or our operations would produce less wastage, or we will use less energy without sacrificing production. These are qualitative statements. This will not do anymore. You have to have set objectives, that if we are using so much of energy today, will cut down by 10% within the next 2 years. If the air pollution values are so and so at certain locations within the factory premises and outside, we will improve our operation so that the values would come down to some specific values. So, we have to have set objectives. These are the targets that the environmental policy must list down, and these targets must be reviewed from time to time. That have we set good enough targets? Do we need to revisit the targets? Can we do better? Or in case we are not able to meet the targets, were they unrealistic? In that case, should we change them again? But more important, I think the thinking should be there in the first place, which are realistic targets and which are not only realistic, but which are desirable targets, and the subject of review would be to see if we have failed to meet the targets, why we have failed to meet the targets. If you have done better than what the targets demanded, then we must make the targets stiffer. It is like the changing of the goal posts. As you go near the goal post, we say, okay, the goal post is too close, so move it behind. So, this is always happening in the industry. So, not only set objectives, but review the targets. Then according to the set objectives and reviews, we operate to comply with laws, statutes and regulation. Not only we comply with what we have set for ourselves, they cannot be different from the laws, statutes and regulations set by the government. Ideally, your objectives should be to reach a situation which is better than that demanded by the laws and statutes and regulations. That should be the minimum, but any sensible company would like to do just not comply, but do better than that. And to do that, we have to have plans to reduce consumption and wastages. We should have a policy to recover and recycle material wastes. Please ignore that E in front of R, recycle material wastes. We must phase out pollution prone processes. That will be part of the environmental policy, that the processes which are pollution prone must be phased out and upgrade technology. An example that I have quoted earlier and I can quote again, in the copper metallurgy, the traditional roasting and reverberatory smelting processes were extremely pollution prone. Not only they generated pollution, they also wasted energy. So, the technology was upgraded to flash smelting, and in some other countries it has gone to the level of continuous copper smelting. The policy has to do something about rehabilitation of waste dumps. In many industries for decades together, wastes have been dumped. A policy has to be found to clear those dumps. This is happening in many steel plants, where for years these they dumped at one place slag from the blast furnace, elsewhere slag from steel making furnaces. And I remember when you went to steel towns, especially the ones that were older like Jamshedpur, there were hills actually. Hills were slag dumps, and there were railway tracks on top of the hill. The ladles will bring in slag and dump it. So, periodically the hill would become higher, the railway tracks would go to a higher level, and the hills went on rising and rising in height. But now, they have taken policies to make use of what is there in the hill, so that the hills gradually come down and disappear. Today, steel plants do not have these dumps in and around the works, but in many of our non-ferrous metal industries, there are dumps. The synthetic rutile plants I mentioned, which is rejecting iron rich, may not be, they are maybe a small dumps, I may not call it a hill. The red mud from aluminum industry, they are not making hills, but they are in ponds. There are a huge lot of them. So, we have to find something about rehabilitation of waste dumps, so that we can reclaim the land that they have occupied. Maybe we can find good use of them, which will be profitable for the company. And lastly, the environmental policy must aim at developing awareness amongst the workforce, because the policy should not be only the policy of the management, it has to permeate down to the workforce. It is very similar to the quality policy that many industries have now adopted. When we were students 40 or 50 years ago, there used to be in every industry something called manufacturing industry, quality control and repair. So, the products were produced, they came to the quality control and repair section, they checked it whether they are fit enough to go to the market. If the product was not fit enough, first they tried to repair it. If it was beyond repair, it was sent back to the works to be used as scrap. Now, this quality control and repair section was a very important section. Sometimes it accounted for 1/3 of the workforce or the materials that they consumed. It is very important, but eventually it was understood that if you have a place where quality is being checked, the rest of the plant thinks quality is not their concern. They just want to produce and let them do the quality checking. So, the entire operation became error oriented, defect oriented. So, in the last 40 years things have changed. We do not check the quality at the end, this will be end of pipeline solution. The idea is to have a control of quality from the beginning itself, so that we ensure quality in every stage of the process, and we do not need an end of pipeline solution. For that, there has to be awareness amongst everybody at every level in every step of the process. When we want to do something about the environment, the approach is something similar. We cannot have end of pipe solution, that let anything that is happening, let everything happen, and then we worry about control after things have happened. We would have to ensure a concern for the environment right from the beginning, and that cannot take place unless the workforce is made aware. Now, when you have a policy, there has to be a procedure for implementation of the policy, and the steps in that procedure for implementation of a policy are as follows. There has to be an evaluation of environmental aspects and their impact. We cannot talk about a policy unless we have facts and figures. So, we find out the environmental issues and what impact they are making. We need to have access to legal requirements, because we have to comply with legal requirements. All the literature has to be made available, documents, statutes, laws, they should not only be available, but people, management as well as people down below must be made aware of these. Next, there has to be an organizational structure with responsibility and authority. If you want to implement something, it cannot be a wishful thinking. You need to have a structure, people in places of authority with powers. They have to have all that is necessary in terms of incentives and disincentives to enforce what needs to be enforced. If through awareness or through education, otherwise enforce very strictly using the authority given. So, we need an organizational structure with responsibility and authority. There has to be training, that you cannot impart something unless those who have to accept that know what is to be done. So, down below, from bottom to the top, there has to be training, need of training and how to impart the training, which would have to be based on communication day in and day out. And that has to come through commitment from the very top. Of course, the managing director cannot go and talk to everybody, but he has to talk to the colleagues 1 or 2 ranks below. They have to go and talk to people below them. Even the top can meet the rank and file sometimes and talk. So, there has to be a lot of communication. And things cannot be only verbal, there has to be document control. Everything that needs to be discussed and communicated must be documented, and discussions or awareness programs will be based on these documents, which means there have to be different kinds of documents. The documents you make available to the top management would be different from the documents you make available lower down. Things may have to be written in very simple language for the labor in the shop floor. They also then feel enthused, they become part of a big thing. Let me tell you a story here. There were some stone cutters cutting stone in a quarry. Somebody went and asked the stone cutter, "What are you doing?" So, the stone cutter said, "Well, I am an illiterate man, I cannot do anything for a living, I am cutting stone just to make a living, so that I get something to eat today, maybe I save something for tomorrow." Here is a man who is doing the job because he has to do the job. He goes to the second stone cutter. The second man says, "Look, I am cutting stone and I am very good at it. You go anywhere, you find nobody can cut stones so beautifully and so efficiently, so fast." So, here was a man doing the same job, but he had a pride in his work. He wanted to make him better than others. So, he was one step higher than the other fellow who was simply resigned to an activity. Then this man goes to a third fellow, says, "What are you doing?" He says, "I am building a temple." He is doing the same job, but he sees it as part of a big project. In his mind, he has become a partner in a big project. Similarly, when we talk about an environmental policy, we have to give to the workforce a big vision. They should not do something just because they have been told to do, or somebody should not do it because he thinks he can do it better than others. He or she in the workforce has to believe that he or she is part of a vision, part of trying to create a company which will be cleaner company, more labor friendly, more friendly towards the society, more tuned to the future. It is not only for making profit. So, that vision has to be given through communication and through document control. Now, to ensure that the policies etc. are well taken and well imparted, the management also has to be responsive towards the people. So, there has to be response to accidents and emergency situations, which may or may not arise out of defective technology or environmental problems, but there has to be quick response. There has to be strict adherence to process control, because no matter what technology you put into an industry to control things, and very often things when they are in control is when your environmental problems are less. Even when you are driving a car, the maximum pollution is generated during startup and acceleration. When the car cruise at a steady speed, uniform speed, it does not emit that much of polluting gases. Similarly, in an industry, if things move smoothly, so the undesirable effects are less. But if things are bumpy, that lot of production one day, less production today, the quality is changing, output is changing, then you create disorder, you create more pollution also. To make things steady, we need process control, and computerization that has been introduced today in many industries is ensuring that the things go on smoothly. You bring in raw materials of a consistent quality, the operational parameters remain constant, the product goes out with a quality that does not vary too much with time. We need process control. We need corrective and preventive actions that may be necessary, and we must have record keeping. Everything that is being done, all analysis of input materials, all analysis of products, all data regarding the parameters that have been set for the process, they must be recorded. Because in future, if you want to make further improvements, or if we are to analyze some undesirable effects, we cannot do so unless we have records, because we have to refer to the records and see what went wrong and what needs to be set right. Then there is called systems audit and system review. I will discuss that little later. By the word audit, we mean a scrutiny and analysis of every step and every detail with reference to a particular goal. Like if you want to do financial audit, then everywhere you find how the finance has been handled. If you want to do energy audit, then you go to every section and collect data to see how much energy a section has consumed in comparison to another section, and that comparison to another section, so that we can make a comparative analysis and see if is anybody wasting energy. See, if you go to a steel plant, it is well known that maximum energy is consumed in the iron making section. The figure is more because we are consuming coke, which is a form of energy. Next would be rolling mills. In steel making, less, and if you go to the ore beneficiation section, it is even less. Now, if you want to save on energy, it is only when you have this data through energy audit that you would know where we should put on priority. In an office building, if you want to save on energy, we do an energy audit in different divisions, and we can find out which division is consuming far too much. Then we go and tell the division, look, there is a problem here, let us analyze. So, unless you have the audit for the entire system, we cannot improve the system. And after we have done the audit, we have to review the functioning of the whole system. That is what is called systems review. What are the environmental aspects that an environmental policy must take into account? There will be emission to the atmosphere, discharge of waste water to water bodies. So, we cover air, water, then waste management and disposal, solid waste management and disposal. Then there is another category, special category called management of hazardous wastes, which could be solids or liquids or gases. Hazardous waste substances means of particular nature which have more adverse effects on humans, animals, plant or property, hazardous. We talk about contamination of land. Are we introducing into the land something which is a contaminant? We need to talk about, think about noise, odor, dust, vibration. We need to consider use of natural resources, particularly energy sources. Can we minimize? Can we go for alternative resources? And likely breach of legislative procedures. Are we sticking to the legal requirements? Now, here I come to an extremely important subject. This you may need if you are in any plant, and so you better try to understand. How do we set criteria to evaluate effects on environment? There are environmental problems, gases, water, solids. We know they are bad. How do you know how bad? Because unless we measure, we do not know how to go about remedies. A German philosopher once said, and that has been repeated by many people, that you have to first define, then you have to measure. Once you can define, then only you can measure, and once you have measured, then only you can analyze. And when you have analyzed, you can control, and when you can exercise control, you can improve things. So, there are 5 steps. You must define, you must measure, you must analyze, you must control, and then you improve. Now, in my lectures on energy and environment, I have been trying to go through these steps. We have defined things. About measures, I have not discussed much. We have talked this and that and everything, but how do you go about measuring? A simple way of doing that is by looking at the response that pollution is bringing in the workforce or amongst the experts, instead of analyzing how many diseases it has made or how much damage it has done to buildings, animal, plant, etc., because that will be very difficult to estimate quantitatively. So, we have an indirect procedure, and this procedure is shown in this table. This is what many plants actually practice to measure the effect of the pollution that is there in their plant. Let us see how they go about this. There is an element of subjectivity, mind you, there is an element of subjectivity, but then when a good number of experts are giving their opinion, discussing among themselves, then the subjective opinions begins to become far more meaningful. If you look at the procedure, you will begin to admire the inherent worth of it. We first set the criteria of the effect on environment. What is the area that is affected by the problem we have in the plant? Suppose we have an operation which is generating a whole lot of dust. We have to find out how much of area is affected by that dust generation. Then what is the severity? They would again be defined in the next column, but see the first, the main criteria: area affected, severity of the pollution effect, duration. Is it happening only for a day, for a week or more? And then frequency. How frequently does it take place? This has been devised in a very famous industry. I would name it because they may have changed by now, and I like it. Now, let us see. Let us see now, these have been further identified. Area, very localized effect, not there is a spelling, please, I will have to change this. Very localized effect is happening in a very small area. Departmental or area wise effect, slightly bigger. Entire works is affected, surrounding community is affected. There is a global effect. Like if you generate CO2, there is a global effect. But if you are generating dust from a container, it is a very localized effect. There could be something which has an effect on the department, some may be on the entire works, and these are given different values. Localized effect 1, departmental or area wise 2, 3, 4, 5. These are arbitrary. You could say why not 1, 4, 9, 13, 18. You could do that, but it is a question of grading, and after a lot of discussion they have said this is good enough. Like even in academics, you give A, B, C, D and certain values are assigned. As regards severity, again they are put into 5 categories. Insignificant effect, momentary significant effect, injuries effect on less than 10 persons in a minor way, injuries to more than 10 persons in a, it should be in a minor way. Duration momentary, impact for less than 2 hours, impact for a day, impact likely to last for a period exceeding 1 week. Again these are given values 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Finally, frequency. How frequently does that operation take place? Once a month, it is given 1, once a week is more serious, once a day even more serious, several times a day more serious, continuously occurring. And after we have picked up a certain activity, we give these grades, then the total score is x into y into z into f. Please remember it is not plus, it is multiplied. Why it is multiplied? If it was plus, it will mean that if this score here was not there, it will simply disappear. But multiplication, in multiplication no term can be ignored, it will have an effect. So, we multiply everything, all the scores, x into y into z into f will give you the total score. Now, the higher the score, the bigger is your problem. The idea should be to minimize the total score, which means everywhere our goal would be to go from 5 towards 1, 5 towards 1, 5 towards 1, 5 towards 1. We must find methods of minimizing each of them. because they are multiplying each other. I do not have the time to take up a particular example, but you can do it for yourself. In any operation you consider, this can be applied. Maybe you need some modification here and there depending on what you are concerned with. Now, let me come to a general topic again about waste management. Waste management means several things. It means avoidance of wastes, recycling and reuse of wastes, minimizing adverse impact of disposal of these wastes on the environment. Three things. If possible, avoid generating the waste. If you are not able to avoid, the waste is generated, find a method of recycling or reusing the waste. Suppose you are not able to generate waste and you are not able either to recycle and reuse, but then we must find to keep the waste in a manner that the adverse effect of disposal on the environment would be minimum. Take the case of nuclear wastes. Now, nuclear reactors would produce spent fuel. There will be other wastages which are radioactive in nature. We cannot reuse them. So, we have to finally dispose in a manner that they will be safe from the point of view of environmental degradation. What is done today, I mentioned earlier, first of all that will be taken into glasses. In molten glasses, you dump all that, so that when the glass freezes, everything is locked in there. That glass will have to go to several layers of steel containers. Those containers would finally be dumped in the sea or deep in the land under the rocks or whatever. You do the best you can to see that the waste does not pollute where it is kept. Unfortunately, in the industries today, nobody had, not everybody has the awareness or the technology or the training or the mindset to do this. Obviously, it is going to cost little extra to do this, but it has to be done for the good of the society, also for the image of the industry, for the good of their own people. All this comes under environment management system audit and environment management system review. So, when there is an environmental policy, the environment management system is put into place, that how will the whole thing be done. First of all, the chain of authorities, then documents with them as to what is the policy, what are the activities, then how will the activities be implemented, reviewed from time to time. All that will come under environment management system. Once it is in place, it has to be audited. Periodically, one has to go and see, and there has to be this systems review time to time, that is this system that we have designed, is it good enough? And once we think, okay, this stage now, then we do the audit. What is happening where? Is something happening somewhere that should not happen, or is a section doing better than the other section? If they are doing better, why they are doing better? If they are, some section is not doing well, why they are not doing it? All will come in the purview of audit. How does the management proceed in this? And one day you may be in the chair to do this. You have set in motion policies, procedures, implementation, but the management has to review from time to time, and the agenda for management review will go like this. First of all, last minutes. What were the decisions taken last time? What are the actions that were recommended by the audit section? So, what was the result of the EMS audit? What all did they recommend? What was the action plan? So, then we come to third, progress of environmental management programs. How are they progressing, including the original activities as well as those recommended later on. Performance against objectives targets. Every section was given a target. What has been the performance as against the target? We have to measure, we have to grade them. We have defined things, now we are measuring them, and then only we will control, analyze, control and improve. So, the systems review is a process of analyzing, and then only management will have to take decisions for control and improvement. We look at results with respect to legal requirements. Are we meeting them? Are we meeting the resource requirements? That for implementing anything, we need certain resources. Do we have them? People, technology, materials. Is there sufficient work in the area of training and awareness generation? Possible needs for changes, any other relevant issues. So, this management review system will do this periodically, if not every month, every 2 months, always with reference to what happened last time, what were recommended to be done subsequently, an examination were they done subsequently, is anything new to be done, if so, what all inputs will be required, possible needs for changes, and while discussing some other relevant matter can come in. This is how an environmental policy is taken forward in any industry, and non-ferrous metal industry will not be an exception. I will discuss now one particular industry which is the biggest polluter in non-ferrous metallurgy, and that is the aluminum industry. This subject assumes greater importance because this is the flagship activity in a non-ferrous sector in our country. No other metal come anywhere near the quantum of production as compared to aluminum, and this sector has to grow. It has to grow because we have bauxite deposits in plenty. We have the skill, we have the knowledge, we have the workforce. We do lack power, which is the need of the hour so far as the aluminum industry is concerned. Hopefully, that would be solved, because without energy, the country cannot progress, not just the aluminum industry, the entire country cannot progress. In any country, GDP is proportional to per capita energy consumption. So, if we want our GDP to grow, our energy production and consumption have to grow as well. So, from the point of view of non-ferrous metals production, aluminum assumes the most important position. Now, if you want to talk about pollution in aluminum industry, we would again have to discuss the effects in terms of local, regional and global effect of emissions, because their management and their implications are different. What are the local effects, local issues? Release of fluorides that cause bronchitis, dental and skeleton fluorosis. So, population around aluminum plants, smelters would have the problems of bronchitis, they will have dental problems, the skeletons will become weak, the bones would become brittle. Then there is a regional. Regional means say several kilometers around the plant site. Pollution effects will come from CO2, SO2 released, and these gases can be transported over long distances, swept by air or washed away by rain. Rainwaters will make them fall to the ground. These are acids. You will have CO2, SO2 will pour acid, acid rain will go to the ground. It will reduce growth of vegetation due to acidification of soil. pH of rivers and lakes goes down, and then fish cease breeding and eventually leave the area. Acids also aggravate corrosion of structures, buildings, metal structures, everything. This is a regional effect. It can go to quite a distance from the plant site. Then there is global effect, the increased CO2 in the air, the CO2 coming from the electrolytic plants. This will contribute to greenhouse effect and global warming. The entire world is affected by every contribution to global warming, no matter from where it is coming. It may be small, but it certainly is a contribution. We also have not only CO2 or SO2 in air, there are air pollutants, soot, alumina particles, cryolite particles, other aluminum sodium compounds, fluorides. Then there are gases, hydrofluoric acid, CF4, C2F6, SiF4, SO2, H2S, and a whole lot of them hydrocarbons. They are all going into the air. So, they contribute to local problems, regional problems, as well as global problems. Now, aluminum industry is a big polluter, and the industry is trying to find solutions, but they have not found solutions yet for all the problems. One thing that is not mentioned here is that we have carbon cathode and carbon anode. Time to time, the metal is going to the cathode, which makes the lining of this electrolytic cell, but the Soderberg anodes or the other anodes where we are generating CO2, they get poisoned by fluorides, and they have to be thrown out from time to time. This is a problem, because all the poisoned electrodes are there in a dump. People do not know what to do, because you simply cannot crush and grind and put it, use it for landfilling. You cannot, because there are fluorides in them. They are poisonous substances. So, industry simply sits with the dump, still not knowing what to do with it. We do not have a proper process for handling that waste dump. Now, it is a bit difficult to read, so I will quickly go through this and end the lecture here. You just listen what all things. It actually gives some principal wastes of the aluminum industry and their use. People have looked at it and found there are uses for it. In bauxite mining, laterite, which contains all kinds of minerals, the overburden that has been taken out from the top, there is dust, all these are coming from bauxite mining. Fortunately, they are non-toxic, means they would have go to respiratory problems and other problems, but no serious health damages. They can be partly consumed through blending, landfilling they can use, they go for cement making, refractory, oil and refining industries, etc., etc. Mostly landfilling we can use all that. After we have removed the top, then for bauxite mining, we end up with red mud, the bauxite residue left after the extraction of alumina by bare process. This is toxic. It is partly used for bricks and corrugated sheets, dry disposal to conserve land and possibly recovery of Fe2O3 by HCl route, they are being tried. Dry disposal means we do not allow too much of liquids to go with the red mud, but then there is a problem that they can fly around. So, they keep them slightly moist. Then we have vanadium sludge, the bare process liquid on chilling precipitates a soft wet crystalline mud that is toxic. Soda is neutralized and V2O5 is recovered for ferrovanadate production. So, vanadium recovery is being tried. Power and steam plant, we generate combined power and steam, where the steam goes for the autoclaves. This is non-toxic, fly ash is non-toxic, is disposed in slurry form to ash dikes and used to make bricks and cements. People are finding use for fly ashes, but there is a problem here. In many countries, say in Europe, Poland and all, they do not allow use of fly ash bricks for making houses because they are radioactive. They are allowed for making roads and other things, not at all for houses, not where too many people are coming in that environment. In our country, we still do not have that restriction. In the smelter, there are toxic things coming in cathode carbon, as I said, the cathode, not the anode, I mentioned wrongly. The cathode carbon crumbled and deformed spent cathode made up of anthracite as well as metallurgical coke fractions bound with pitch, etc., etc. It is a toxic thing, disposal in confined area and incineration for recovery of fluoride salts. At the most, the whole thing can be burnt, carbon is burnt away, the fluoride salts are recovered. It is the cathode that is disposed, anode gets consumed. So, there is no problem with that. Refractories also give non-toxic, they dispose in confined area, and then we have primary smelter gases which are toxic. We can only think of stack disposal of clean gas, recycled or regenerated cryolite in cells, and incineration of ESP dust to recover cryolite. So, the gases that are coming out, we might try to recover cryolite from that. So, there are all kinds of things coming out of in the aluminum industry. Solutions have found partly, sometimes wholly for certain things, but there is lot remains to be done. We will continue with it in the next lecture. So, thank you.